Alright, so hopefully this time you guys can hear me. Alright, let's go through. This is what do you already know about chemical reactions. At this point, you know the different types. We did an experiment on exo and endo. You know that new products are formed with totally different properties. And that's really the main idea. Okay, it says a chemical reaction is where a new substance is formed with different chemical and physical properties. That's basically what I just said, but you should have this in your notes. Gives you example in the picture. Hydrogen atoms are by themselves, oxygen by themselves. Hydrogen is explosive, so is oxygen, actually flammable, but together they make water. Okay, you should have all of this in your notes. Chemical reactions always result in a new substance. The reactant is always on the left side of the arrow, and the product is always on the right, so the arrow should always point to a product. Reactant is what goes in, and a product is what comes out. Energy can either be absorbed, which would be endo, or released, which is exo. Okay, it says a reaction can only happen if the elements bond. So if I asked you what kind of reaction would happen with a noble gas, you would tell me no reaction because they cannot bond. Okay, it says if you are a chemist working in a lab and you witnessed a chemical reaction, how would you write this in your lab book to accurately show what took place? You would use a chemical reaction equation. So in this equation, it shows you two magnesium atoms mixed with one oxygen atom, or actually we should say bonded, creates magnesium oxide and the release of energy. Okay, so that's everything that's being said just in that one little equation. The law of conservation of mass in regular words. I want you to write what's on the screen, but if I were saying it to you, it just means whatever you put in is what comes out. You can't put in 15 milligrams if you see in the picture and have a different number on the other side. After the reaction, it has to be exactly the same. I'm going to skip that for now. Okay, so balancing chemical equations. You should know what a subscript is, a symbol, a formula. These things cannot be changed. Okay, the only thing we can change to balance an equation is we can add a coefficient. We balance equations to show that no mass has been lost or gained. Remember, we're trying to prove that whatever went in is exactly what came out. So in a minute, I'm going to show you an equation with these things labeled, your subscripts, your symbols, your coefficients. You actually don't need to know these 4 types of reactions, so we can skip all of this. Okay, thermic means heat. Think of a thermos. It keeps anything hot warm. Thermal underwear, if you're going hunting, keeps the hunter warm. A thermostat controls the heat in your home. Okay, so thermo or thermic always means heat. Exo, think of exiting means leaving. Endo is going into, so exothermic reaction is the leaving or exiting of heat. So this one would become hot. You guys have seen these reactions in class, just last class. Endothermic is when it's absorbing all of the energy and it makes anything around it very cold. Okay, so over here we can see in this picture, it started at 40.5 degrees and it went up to, or down to, 5.8. So this one is endo, it's getting very cold. This one, you can see it's heating up, so it's exo. All right, if your mother or father received a new credit card in the mail, it has what we call an activation code and a phone number, and it tells them they need to call the number to activate their card. So what do you think the word activate means? Hopefully you said it means to begin or start, and that's exactly what it means. So in chemistry, it doesn't mean anything different. It still has that same meaning. Activation energy is what's needed to start the reaction. Kinetics is the science or the study of reaction rates because not all chemical reactions happen at the same speed. Think about lighting a match. It happens very quickly, but a bike rusting happens over a long period of time. It's very slow. Okay, reaction rate is how quickly or slowly a reaction occurs. The collision theory. You have to picture the atoms. Okay, so the atoms are all next to each other, and if one of them starts a reaction, it moves and hits another atom, and that one reacts, and then it hits another one, and they all collide together. And so the two big things up here to remember as far as collision theory goes is temperature is going to speed up the reaction rate. It's going to speed up the collision theory or the collision, I should say. Because if you heat up atoms, they start moving really fast, and so that act of bumping into each other is going to speed up, causing the reaction to go faster. A catalyst is anything you add to a reaction to speed it up. But more importantly, it's something you add to speed it up that doesn't change the reaction. In other words, it can't be a chemical that you put in there that made a whole different reaction happen. It has to still be the same two things or three things reacting. This just sped it up. Okay, rusting is sped up by salt. But the salt doesn't react in any way. It actually just speeds up the rusting. So it would be a catalyst to rusting. All right, so here is an equation. I know it looks crazy. We have 2H2. The little number right here, this 2, I'm going to circle it, is your subscript. And we have a plus, and I put a wall around the plus, and today we're going to go over why I did that. Your symbols are your H for hydrogen, your O for oxygen. Those are symbols. Your coefficient are these big numbers that I added. There's 2 here and there's a 2 over here. That tells me how many molecules I have. So I have 2 H2O molecules. Over here I have 2 H2 molecules. And at the end of it, I end up balancing this equation so that whatever I have on this whole side over here is the same as what I have on this side. So my reactants over here match my products over here. And today we're actually going to practice this. All right, so finally you can hear the lesson. I'll see you guys in class. Bye.